Okay, the lab related to the SR, there will be totally 5 labs, 3 for SR&MPRs and 2 for SRv6. Those 5 labs are all did in a manual way. I mean, there's no controller involved, so totally will be 5. So for SR&MPRs, there will be SR&MPRs BE, SR&MPRs TE, and SR&MPRs policy. And BE and the policy will be most widely used. And for SRv6 will be BE and SRv6 policy. Okay. So here is have some like the part like the IP address setting. It's already recommended here, and at the very beginning, this is all IP address setting. This part already finish the configuration, and here just let me do the configuration for the rest part. Let's do the SR&MPRs BE first. Okay, do a demonstration here. So anyway, a very typical ISS configuration. Level 2 wide NET ISS name. Okay, IS name, nothing special. Let me do the fast configuration. Okay. Cost wide and its name P1. Okay, then just all the interface that is connected to each other, we will enable the ISS. During this time, we just this is just a normal ISS configuration. Okay. So this is all just the basic configuration. Let me do it quickly. Use a copy and paste. Because I guess this configuration is too much easy for you guys. So let me use copy and paste and to make it fast. Okay. Save some time too. Just save some time. Wait a moment. Okay, let's do copy and paste because this configuration is nothing difficult, nothing special. Okay, so for the P2, okay, let's do copy and paste. This configuration is too simple. Just enable the SS, that's all. And the P1. Now let's configure the P3 first. P3, this become P3. This will be 3, 3, and 3. Copy and paste. P4, same thing. P4, 4, 4, and 4. Okay. And for P1 and P2, there will be one additional interface. The rest is same. So this basic configuration, let me just do it quickly. This for P1. This is 5, 5, 5. Okay. Okay, and the P2. Do it quickly. Just establish some normal RSS neighbor. Okay, so we wait a while. While we're waiting, let's see the rest configuration. The RSS, I guess it's very simple. And for the MPRS SR&SRv6 LAB, this is also very simple thing. This is just the normal MPRS, right? Nothing special. Like because we are doing the SR&MPRS TE, we're still using the MPRS. So this configuration, we just all needed to do the configure. This I directly configure. Okay. This is a 5.5. This is 6.6. Or maybe this might be a little small too. This font is maybe too small. Okay, let me make it big. Let me zoom in so you guys can see it. Okay, let's continue. MPRS RSID 10.0.4.4. This is normal configuration, and let's check the ISS display ISS routing table. Say if we got everything, 1, 2, 3, 4, 5, 6. Yeah, it seems okay. Look at P1 neighbor display ISS up here. P1, P3. Okay, no problem. Okay, ISS, no problem. Oh. Okay, no problem. Okay, no problem. Then let's continue. We finish the configuration of the MPRS, and we actually also needed to. I forgot to enable the MPRS function. I forgot to enable. Okay, now we actually need to enable the MPRs for each interface. Later maybe. Oh, you do not need to. Because we enable it in the globally, defaultly it will be enabled in the interface. But if you are not quite you can enable in the interface also. But anyway. Because by default, this devices is enable the will automatically enable the MPRs, but you also can put the configuration by yourself. Okay, then we need to do the configuration for SR. So for SR, first we need to define the sRGB, right? The range, and also we need to identify our node seed. Our node seed, we need to identify it. So let's do it one by one. Okay, this might be, if you do not configure the segment routing before, here is how to do the configuration. First, enable segment routing, and in the RSS1, because we need the RSS help us to forwarding to advise the segment information. Okay, like sRGB, like the index. This is what we need RSS help us to do. So about the range, you can write any range you want. Okay, then we go to loopback. Use loopback as the node seed. Okay, so RSS prefix seed index 1. Huh? What is IP address? Yeah, this is right. Info. Oh, okay, this is just info. No problem. Okay, then in the PE2, we're doing the same thing. Let me copy and paste. This part is all same. Let's do the copy and paste. Okay, in P1, also doing the same thing. P2. P4. Okay, now we set our every device. Let's go back to the to this part. Every device they are enable the segment function, And this second function is SR&SRv6, and we set the SRGB. Oh, dear God, the index is wrong. Sorry. The index, and the index, I set is wrong because the index must be unique. Index must be unique. This index is true. Okay. Sorry, the index must be unique. I put it wrong. Index 3. This is 4. Oh, there's a question. What is the function for sRGB? Well, the function for sRGB is the range, like because SR&MPRS, we're still using the MPS label, right? So we will give the SR&MPRS a block range, the label range from here to here, and the SR&MPS label will be the label number will be in this area. So we just define MPS label zone, which will be used by the SR. So this is sRGB. If you do not configure the sRGB, the segment routing, this function, cannot how do I say this? Assign the label to the prefix, cannot assign the label to the interface, cannot assign the label to the VPN instance. So you must define it. If you do not define it, the SR do not know like where to withdraw the. Yes, same thing. Yeah, sRGB is equal to MPS label pool. Yes. Where did I come? Function is same, but this label pool is just dedicated for segment routing MPS, dedicated for MPS. Index 6. Just must remember. Yes, instead of using LDPT, we use SR to allocate the label. Yeah, and that label which will be allocated by SR, those label is in this label pool. Okay, then let's continue. Where are we now? We just finished to configure the segment routing, and we define the node seed for different devices. A very important thing, index must be different, otherwise we will got a problem. Okay, index must be different. We can check the terminal info. Right now, we already can have something right now. Display terminal info. Oh. You can see we already can have something. This, you can see it is SRB LSP. Those kind of information is being exchanged by the IGP. So we do not need to configure LDP or anything. So so we also can see this display segment routing prefix MPS forwarding. So we can say for each network, for each destination, we know where it is, and we can see the label. There's 1, 2, 3, 4, 5, 6. Sometimes we have two paths because they are ECMP, right? They are ECMP, so sometimes we got 2 paths. So you can see this the last number will be the index. Okay, we actually already can ping the RSP, but it's not. We can do a little bit of ping if we want. This is ping the BE kernel, but not very important. 10.0.6.6.32. If you want to follow with a version draft, it's okay, no big deal. Anyway, we can ping the RSP, right? Use segment routing. Okay, now let's put the VPN into it. Put a VPN into it. The network is planning this way. For the PE, we have. Oh, sorry. For the PE, we actually have display IP interface brief. We actually have a loopback 1. This will be work as a this will be simulator's endpoint, the terminal. Okay, so I will use the P1 this IP address to ping P4. This IP address, and those addresses will belong to certain VPN. Let's create some VPN. Let's call it VPN A. VPN A, capital letter. We can set RD. 10 and the VPN target. This based on yourself. I mean, as long as you can make them like work together. This is a P1. Let's do the P4. VPN is VPN A. This is just I guess everyone is very familiar with this right now. It's not a big deal. VPN target. Okay, so let's put the loopback 1. We are using this IP binding VPN instance, VPN A, IP address 10.1.4.4.32. Okay. So we will use loopback 1 as a how do I say this? As a VPN terminal. Okay, VPN A. So 2. Did I commit? Okay, after this, we just create a VPN v4 neighbor relationship with P1 and P4. Okay. In this lab, they actually create a lot of neighbor relationship. They are using the P1 as a RR. Okay, let's look at the topology. They actually using P1 and P2 as a RR, and the P1 connected to P1 and P2. P2 connect to P1 and P2. So the rest of the thing is same. Okay, let's just follow the lab guide. No problem. Just a little bit of configuration. No big deal. Okay. So P1 and P2 is RR. So let's create a BGP. Undo. Because I do not want to create the IPv4 family. So let me undo it. Here 10.0.5.5 S number. Here 10.0.5.5 connect interface x0 and IPv4 VPN v4. unicast. Oh, I forgot to configure with 6 and 6. Oh, okay, wait a moment. Let me do the copy and paste. In P2. Oh. Y. Wait, should I put a Y here? No Y here. And the commit. Okay, and 3, P3. Okay, P4. Okay, now where are we? That P1 and P2. Undo default PV4. Here 10 0.1.1. Wait a moment. Let me do a little bit of configuration. It will be very fast. Okay. Oh, no. Then undo VPN target policy. VPN target. Because this RR will need to reflect the VPN. The VPN, how does this? The VPN root entry. So you need to undo this. Okay, doing the same thing in the P2. here is y, 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 y. Yes, yes, yes. Okay. Okay. So let's check the. This is all established. Let's check P2. Okay, it is all established. Then we just need to put the root entry into the VPN instance. It will be okay. So I want to ping from P1 to P4. So in P1, let's just create some. Let's bring some VPN instance VPNA. Import root direct. So I will import a root display BGP VPN v4 or routing table. So you can see there will be this 10.10.1.1.1 and P4. This will also have IPv4. No, not static, direct. Okay, then they will exchange the root entry. Let's look at display BGP VPN v4 or routing table. So you're gonna see there will be where's one? One is not coming yet. Wait a moment. Did I forget configure? Oh, I forgot to configure reflector. Oh dear God. I forgot to do it. I forgot. Because it's so I forgot to do it. Wait a moment. Okay, then it will be reflect. Let's check. Let's check P1. Display BGP VPN v4. All routing table. There will be 1 and 4. Let's check the other end. So there will be 1 and 4. So you can see this is reachable. And let's checking the tunnel ID. Display IP routing table. VPN instance VPNA 10.1.4.4 verbose. So you're gonna say this actually we have a tunnel. We actually have two tunnel ID because it is load balancing. And this tunnel ID, let's display tunnel info. Oh no, tunnel info. Oh, let's find 29.006 will be this. You can say this. This is the LSP, right? The destination is here. So they are reclusive how do I say this? They are finding the kernel, right? So we will do a little bit testing. VPN instance, VPN A, 10.1.1.1 to 10.1.4.4. Okay, there will be it's okay. So this is B. Any question for B? It's very simple. It's just similar with LDP. Similar with LDP. Just we do not need to configure LDP anymore. That's all. Okay. Okay. So let's continue about the TE. So for the TE, the rest part is the same. You can say we configure the MPLS, we configure the ISS. This part is all same. So we just pass. So not important. This is all same. This is also same. This we do not do the configuration anymore. So here is something different now. Since TE, we need to define the path, but actually TE do not use a lot. Basically for this lab, for TE, you got an idea like how to do the configuration, it will be okay. Okay. Now let's look at this. We need a we can define the seed. We can define the seed because we can do hop by hop. We can do hop by hop. Then this number, you can say P1 and P2. This number can be how do I say this? Can be same. Those two ID can be same, no problem. Those two ID can be same, no problem. So let's do the configuration. And here we actually only needed to set the configuration for P1 and P2. Why do we not? Why we not do the? Why we not set the adjacency? Here is a setting adjacency seed, right? Why P1 and only P1 and P2 need to configure the adjacency seed? Why P1, P2, P3, P4 do not need to configure the adjacency seed? Okay, let's look at the topology a little bit. Okay, so when we define the SR&SRv6 path, if we based on the how do I say this? If we only based on the how do I say this? Based on the adjacency seed. So when the P1 sending out, they actually only needed to send into the P1. It will be enough. So I send into the P1 and P1 based on this adjacency seed, it will send out. So so here we only need to set the P1 and P2. It will be enough. Adjacency seed only needed to set in this topology. Only need to set in the in the P, because I was creating like this. I was wanted to create what is it? That's adjacency seed plus prefix seed to do the forwarding. I want to send it like this way. Let me describe the SR&SRv6 path again. What I want to do is like this. I finished all the configuration. Now I wanted to plan the path. I finished all the basic configuration. Now I want to plan the path. The path I want to do this. First, PE1 will send into P1. From P1 to P1, I will use the node seed. So no matter you're going from here or going from here, I don't care. I will using the node seed sending to P1. And when it reach to P1, I will use adjacent seed sending to P2. And at P2, I will use the adjacency seed sending to P4, then the P4 will sending the packet to its destination. Okay, still from P1 to P4. Still from P1 to P4. This is my planning. Sending to P1, I was using the node seed. P1 to P2 adjacency seed. P2 to P4 adjacency seed. Okay, so we need to set the adjacency seed in P1 and P2 first. Let me do the copy and paste. This is for P1. And as I said, for the adjacency seed, this can be duplicated, no problem. Oh. Okay, now we need to create some explicit path. Okay, then let's do some explicit path. Let's give it a name, PE1, PE4. Okay, now we can set the seed, next seed label, 16. Why this is 1605? Because for the, oh, no. It's not configured at this place. Undo. This is P1. I should set it in the P1. Delete. Do it again. Explicit path P1, P4. Next seed label. So why this is 105? Because the P1 index is prefix. I should check local block. Wait a moment. I want to check the I want to check the index. Display local block. I remember it is this range of segments local block. Directly check the configuration. Because my index is 5, so this P1 will be 1005, and this is a node. This is a node, and the next seed label will be. Let me check. And this is myself, static, and I want going out from which interface? I will send into the P1 first, then send out from G50. So it should be this number, 142337. Oh yeah, this is right. 142337, and the type will be adjacency. Then I will sending out from P2 and with adjacency. Type is adjacency. Okay. Then this part we already finished the configuration. Then in the P4, we need to send back. So in P4, they are doing like this way. They sending to the PE3 first, then sending to P1, then going to P2, then P2 going to the PE2, then going to P1. Okay, so this part is a little bit complicated, but well, you just based on your requirement to do the configuration. Let me just copy and paste, because everyone has got the gist. It's not just planning the path, so hop by hop. Okay, and after that, let me enable the function for TE. Only need to enable at the source device, because P4 is also a source device. So we need to enable the TE in the source device. In the middle device, there's no need to enable the MPRS TE, because the middle device do not need to do any calculation or something like that. So we do not need to do it. Then for the SR MPRS TE, we need to create the tunnel. This is a little bit complicated, but well, it need to create a tunnel. And this tunnel, we can use the loopback 0 IP address. But if you want to use your own IP address, also okay. And the tunnel protocol is MPRS TE. Destination from one point to another point. Destination is 10.0.4.4. This destination, this IP address must be same with the VPN routing, the BGP VPN before route next hop. This must be same. Okay. And MPRS signal line. They actually have RSVP, but of course we are using segment routing, so we will use segment routing. And tunnel ID must be same. Tunnel ID, let's put it 1. And the MPRS TE explicitly T pass explicit pass. This is from P1 in P1 is P1 to P4. So in P4 doing the same thing. Tunnel 1 MPR IP address unnumbered. We borrow the IP address from loopback 0. And the tunnel protocol is MPRS TE. And the destination 10.0.1.1. And the MPRS TE signal line. Oh, no. Signal protocol, we are using segment routing, and then MPS TE tunnel ID, put it 1, we must put it in same, and TE pass, explicitly pass P4, P1, this is explicitly pass name, right? Okay, now we just need to lead the traffic into the tunnel, it will be okay. But we can check the tunnel info. Display tunnel info. Off. You see there will be SRT tunnel and the state is up. If you want, you can ping, but here let's save some time and we just pass it. And about VPN, we already configure. So this we just pass. Like do the configuration, we already finished the configuration. And about the route entrance, we already finished it. So no need to do the configuration. This one we already did it at the MPS BE, so we just pass. Okay, this is all same. Now the important thing is here, tunnel selection. Because by default we are selected with the BE, we select the BE. We can check the VPN routing table right now. Right. Right now we are still using the BE. Use the BE tunnel. We can check display tunnel info. Or we're still using this, but what we want is this. So how to do it? We can use the tunnel policy to do it. No. Tunnel policy. Let's say tunnel policy. This is TE. Okay, then we can select the tunnel sequence. Select the sequence. We are using the SRTE. Okay, then we actually do not need a load balance, but load balancing number. We use only one tunnel, and the binding with the tunnel policy with this tunnel policy, no eVPN. It'll be okay. And in the PE4, same thing. We select the tunnel policy TE, select the sequence, tunnel select sequence. We are using SRTE. Just the one will be okay. And also going to IPv4, IPVPN instance. To select the tunnel policy will be TE. Okay, and after that we can check. We can check the you can see the tunnel ID is changed. It changed at the very beginning. It is this. We are using the SRBE now. We are using the SRTE. We can check display tunnel info. Oh, we're using this tunnel right now. And we can check the P4 same display IP routing table, VPN instance, VPNA 10.1.1.1 verbose. This is also changed. We can check. Domain for all. Right, we are using the T. Then we can check in display IP. You can see this interface, outgoing interface is channel 1. Now we can just directly do the ping VPN A from 10.1.4.4. Okay, so it is reachable. Now we are finished the configuration for TE. Then let's look at the SR&MPS policy. Okay. Policy, most part is the same. Most part, this basic part is all same. This is all same. We just pass. This is also same. This is also same. And the there will be different. For the SR policy, TE we are using explicit pass, but here we are using the segment list. We're using segment list. Now we can leave the TE in the configuration. We can leave it. Don't worry. The TE we can just put it there. It will not conflict with the segment. Will not conflict with the SR policy. So TE I can just let it there. Let me continue to do the SR policy. So to do the SR policy, we still need to define the path. We still need to define the path. So here we actually define a lot of paths. Why we need to define like how many paths we define? Like 1, 2, 3. We define 3 paths. Why we need to define 3 paths? First 2 paths actually is this is a segment list for candidate path 1, and the third is for the candidate path 2. Okay, so we define 3 paths here. Segment list, PE1. This is PE1 to PE4. This is first pass, and the index 10. Seed. I just follow the lab guy. Labor. But if you want to use your own path, it's okay. I mean, you basically just based on the interface labor, the adjacency labor, you just plan the path. It will be okay. So it's not a difficult. You can say this is very simple one. Just plan the path. That's all, right? The rest, let me just do the copy and paste because it's not difficult. Let's save some time. P2. Okay, copy and paste. Okay, now we're planning 3 paths. So this path, 3 paths can be used into 3 lists. So this 3 lists can be used in the candidate path. So first, we need to define a policy. So the policy first, they must have a name. P4. SR policy. SR policy. So as we remember that the SR must be defined by the head end endpoint and the color. So the head end will be this device. So we do not need the head end, but the endpoint is what we need to do the configuration. So this endpoint must be same with the next hop for the BGP VPN route entrant. Okay. So the color 100. Now we set two candidate paths. Candidate path 1. Let's go to preference is 100 and the segment list P1, P4 1, and the second segment list P2 2. Okay, then let's do another candidate path. Preference 50. It will be lower than this. If there's something happen, the first candidate path is failed, I will use the second candidate path. And the segment list will be P3. Okay, so the P4 doing the same thing. Here I'm doing the copy and paste about the whole part because they are same. They are all same. They are same with the P1. So let me do in copy and paste. To save some time. Wait a moment. Okay, because they are all same, so let me just directly copy and paste. Nothing special. Okay, they have the path. We already created the path. Wait a moment. Change your name. Okay, and after we define the candidate path, now we just needed. There's one more thing we need to do. Look at the color. How can I let the VPN know that I should go into this color? I should follow this color. There will be three ways, actually two ways. First, you can use the route policy. During the P4 sending the route entrant to P1, we can use the extension extension community to carry this color and tell the P1 that if you want to go into the sending to me, you should go into the tunnel with the color 100. And there's another way is we can directly configure the color in the IPVPN instance. Okay, so let's check what is LAB guide do. Yeah, we can directly use this default color. This will be much more easier. But if you want to write down the what do you call it, the routing the root policy, this is also okay. Okay. So anyway, let's default color 100. It's much more easier. And also we need to set configure the internal policy. This is SR policy. Internal select sequence SRTE policy. Load balancing number is 1. Huh? Kernel type unmixed must configured as unmixed. Okay, then we're going to VPN. Changing the internal policy into SR policy. Oh, yeah, this is correct. And in the PE thing, IPv4 default color. Internal policy. Internal select sequence is TE policy. Load balancing 1 unmixed, and go to VPN A. Internal policy SR. Okay. Okay. Now we can check. First, let me check the internal info. There will be a T policy. You can see it here. It's already up, and the internal ID is this. And let's check the routing table. Display IP routing table. VPN instance VPN A 10.1.4.4 verbose. And you can see this internal ID become this. It becomes SR. So P4 should have the same situation. Display internal info or so there's a SRT policy, which is internal ID. Display IP routing table. VPN A 10.1.1.1 verbose. You can see here is we are using SRT policy, right? Now let's do a testing. Ping VPN instance VPN A from 10.1.1.1 to 10.1.4.4. Okay, it is reachable. Then this is how we do the SR&SRv6 T policy. Okay, so any question for SR&SRv6 configuration? Okay, no problem. Then let's take a break. Then we will show you how to do the SRv6. Basically same. I mean, a little bit different, but the concept, the idea is same. Okay, let's take a 15 minutes break. And after that, I will do the demonstration for the SRv6. about SRv6B and SRv6 policy. I mean, how to do the configuration in a manual way. Okay, so take a break. Okay, so one last lab for today, SRv6. Okay, let me finish this. SRv6 two lab, BE and policy. BE and policy. Okay, so the basic configuration for SRv6 it's like this. First, we need to configure all the IP v6 address, which I already did before. So we already have all the configuration. IPv6 interface. We already finished the configuration. So we this is a connected interface, and we have two loopback. Loopback 0 will be used to create the BGP neighbor, and loopback 2 will be used to how do I say to be used as a VPN terminal. Okay, to be used as VPN terminal. Okay, so anyway, let's get started. Okay, so for the first, all the IP address is being configured, and ISS basically we finished the configure, but we just need to enable the ISS IPv6 feature. It will be okay. So let me quickly do it. This is IPv6 enable. Okay, P2 doing the same thing. This we actually can do the copy and paste. ISS. Wait a moment. Do the copy and paste. IPv6 enable. This one we can leave it. Wait a moment. Let me do a little bit of configuration. P2. Do the copy and paste. P3. Okay, then P1 and P2. Wait a moment. Finish the configuration for ISS. Okay, wait a moment. Okay, let's check IPv6 routing table. We have 1, 2, 3, 4, 5, 6. Yes. 1, 2. This is Wait a moment. Where this came from? This is locate. Oh, sorry, the other one IP address I configure is wrong. Okay, now we finished the configuration for the RSS. We just pass this part. It's just a normal IPv6 RSS because we are doing SRv6, so we need to create the IPv6 neighbor. So that's why we need to deploy the RSS v6 neighbor. Okay. And for the VPN for the SRv6, since we can both carry the where's the VPN configuration? So we can both SRv6 can both carry the VPN v4 and the VPN IPv4 VPN and IPv6 VPN. Both of them can be carried. So you can say here they are using the IPv4, but later if you want, I also can show you about the how to configure the IPv6 about the IPv6. But anyway, this one we did before, so about this we pass. Now we need to create some neighbor relationship for the VPN v4. Let's use the SR&SRv6 BE to carry the VPN v4 neighbor, VPN v4 packet. Okay, so now at the P1 and we also created the neighbor relationship P1 to use P2 and P1 as RR, and P1, 2, 3, 4 is create a neighbor relationship with P1 and P2. This part I don't care. So what is 201:5:5? As I remember, is this IP address? Yes, 5.5. Connect. So I will use this P1 and P2 as a loopback, as a reflector. So wait a moment. Let me undo the IPv4 family. Family address VPN4. Let me clear it first because I have some configuration. 201:5:5 enable yes here 5:6:6 enable yes. Okay, this is P1, and let's check. This part actually we do not need for the IPv6, for the IPv4. Let me undo it. Okay. Okay, good. And for P2, I guess I can undo BGP. Yes. Do it again. No. Why? Okay. Undo. Okay. And 4. Okay, let me do it again. Okay, just wait a moment. Okay, and P1 and P2, we needed to do it again. No. Oh no. Oh, so. colon 1. One, 2, 3, 4. Hmm? Four. Okay. So 2, 2, 3, 3, 3, 2. Wait a moment. Let me use the notepad to make it easy to do the configuration. Wait a moment. Now I need to create the BGP neighbor so we can exchange the VPN traffic. The VPN route. Then going to IPv4, VPN v4. Reflect client. Oh, and undo policy. Wait a moment. One, two, three. Okay. Let's do the copy and paste. Oh, no. Ah, damn it. Enable, yes. Enable, yes. Yes, let's do it again. Okay, and in the P2, doing the same configuration. Okay. Okay, then wait a moment to check if the VPN v4 neighbor is established or not. Display BGP VPN v4 peer or peer. Okay, it's all established. Then we can do the following configuration. Wait a moment. No. It's idle for now. We need to wait a moment. Established. Okay, all established. Now let's move on. Now we want to P1 and P4 the VPN can communicate with each other and based on the SRv6 BE. And let's see how to create the SRv6 BE. First, let's put the VPN instance, VPN A. Let's put it together. Okay, now let's see how to do the SRv6 B. This part about all the configuration for the for the VPN we finished. Now we just say how to create a VPN SRv6B. Very simple. This one is very simple. Okay, first going to the we are from P1 to P4, so we configure this in P1. Now we do the segment routing, IPv6. Okay. First, for the SRBE, we need to we need to set a source address. This will be used as a, when you do the encapsulation, right? This is from P1. So we need to set the source. And also we need to set the locator. This locator doing what? V6. This locator will be used to assign the VPN label. So I will use some special IPv6 prefix. It should not be same with the local address. This IP prefix, this locator, the range, you can set any range you want. For example, you set the FC 01 colon FC 00 colon 1 colon 1696. Okay. The static length is not specified. Okay, let's do some. Let's set the static. What's going on? We need to set the locator. Undo. Let's do the locator again. We need to define the locator. Wait a moment. We need to define the locator. Some part we wanted to do it in a static way. So I should set some area is static. Oh, damn it. Let me undo it. Let me create a locator again. Locator SR&SRv6 IPv6 prefix C00 colon 1 colon. This locator, any locator you want, any prefix you want, just do not use the exist root entry which exists in your. Do not use the network that is located to your physical IP address. Okay. And in the P4 also we configure the locator. Segment routing IPv6 encapsulation source will be 2001 colon 4 as I remember. Yeah, this should be correct. Locator SR&SRv6 IP prefix C00 colon 4 colon 96. We will use static 16 static. Okay. Now let's put it in the P1. Let me think. P1 BGP. And I want this. When I send in the root entrant, to the neighbor, I want them to carry the prefix seed. So ::1, ::6, prefix seed here, 5:5, prefix seed. I should put it into all the devices. This needed to be configured for all the devices. P2. P3. And P4. And the P1 and the P2, we also need them to carry the prefix. So to be 1 and 1, 2 and 2, 3 and 3, 4 and 4. Wait a moment. Make this configuration. And the P2 also same thing. Okay, now after this configuration, when the P1 sending the information, sending the root entrant to the P4, this root entrant will carry the seed, will carry the SRv6 seed. Okay. Now we will just go into the IP family VPN instance to enable this feature. It will be okay. First, IPv4. Then segment IP root best effort. So this VPN will use the best effort, SRv6 best effort to carry the VPN. And also for this VPN, we will use this locator. This locator actually is a range of the segment seed. It is a segment seed pool, this locator actually. So we will use this locator, this segment pool, to assign the SRv6 segment to this VPN instance. And then going to SS and ask them to broadcast the locator. Okay, so actually P4 also need to do. we will use the SR&SRv6 best effort, and we will use the locator SR&SRv6 to assign the segment ID to this VPN, and then we will use the RSS to broadcast the segment information. Okay, now we can check the result. We can check the result. We're not checking this. We're directly checking the terminal. We're checking the terminal first. As I remember, I hope this do not got bug. SR&SRv6. Wait a moment. This display. Wait a moment. Let me directly check the BGP display. IPv6 VPN instance routing table, VPN instance VPN A. Oh, no. IP routing table. Because I was using SR&SRv6 to carry the VPN. IPv4, I was using SR&SRv6 to carry the VPN before root entrance. So you can see the interface is SR&SRv6 BE. They actually already use the BE to carry the traffic. Let's go to the verbose to see it. So there will be a terminal ID. So because SR&SRv6 actually is not a terminal, it's not a terminal. So the interface is SR&SRv6 BE, and let's check the BGP display. BGP VPN v4 or routing table 10.1.4.4. Okay. So let's looking for this prefix ID. This is what we're looking for. So if you find there's a prefix ID here, it means the devices, the P4 SR&SRv6 locator assign this 10.1.1.1, give this 10.1.1 a prefix seed. This prefix seed will be indicated to certain VPN. Let's do a ping here. Let's do a ping here. So it can reach. It can reach. So there's no problem because we can check. Because you can see this going to here. The next hop is a locator. This is a locator IP, and the interface is SR&SRv6 BE. So this is how you do the BE. How to do the BE. Okay. And then last, let's look at the policy. The policy most of the part is same. So this configuration I already finished the configure. So we just pass. So we just pass. This is all same, nothing special. Okay, so we also use the IPv6 family, and now we are using the eVPN to help us to forwarding the to use the eVPN to forwarding the IPv6 VPN v4 root entrant. So we can use eVPN to do it. But if you want to use the normal way, use the VPN v4. This is also okay, no big deal. But in this lab, here they are using eVPN. There's nothing different. There's no big difference here. Okay, it's just eVPN and VPN v4. They actually are quite same. But if they want if in this lab guide they are using it, that's also using it. Okay, this is for the eVPN. Okay, so this is both for eVPN and VPN. Anyway, this configuration actually have no meanings. But anyway, okay, so here do the same thing. Okay, and the rest part we already do the configuration, so this we just move on. And here we also can carry the IPv6 root entrant. This is also okay. And here let's do another IPv6 family address and the root target. VPN target. Oh no, this should be eVPN. P4 doing the same thing. Root target, root distinguish, and VPN target, eVPN. And okay, then let's binding the loopback 2 because we decided to forwarding the VPN v4, we also wanted to forwarding the VPN v6 root entrant. Okay. Okay. No problem. Okay. Back to VPN A and IPv6 address. Okay, so we also will be able to forward the IPv6 VPN information. Okay, now we can use we can create the eVPN peer with the RR, but here to save some time, we directly let's just create it with P1. Already created, and level 2 VPN family eVPN. Okay, let's enable it. Enable, yes. Encapsulation type. So we want them to, oh. We want them to advertise the SR&SRv6 related information, like the color, like the RD, RT, etc. And the encapsulation type. We also want them to advertise it. Okay, let me copy it. Paste. Oh, dear God. Okay, and the P1 and P2 also need to do a little bit of configuration. So to save some time, I only establish the neighbor relationship with P1 and P4. This is undo. Okay. Okay. Now they will be able to forwarding all kinds of information related to the SR&SRv6. Now what we need to do is this way or passing way or finish the configuration. Now what we need to do is trying to establish the SR&SRv6 policy. Layer 2 VPN. This needed to do a little bit of configuration. Means I will sending the root entrance into eVPN. Actually, we also need to configure the IPv6 family VPN instance VPN-A. Import root direct and advertise to level 2 eVPN. This is also need to be configured. P1 also need to do the configuration. IPv6 VPN instance, family VPN instance, VPN A, import boot direct, and we'll advertise those root entry into the eVPN. Okay. Okay, after that, let's do the do this. We need to set the opcode, like the for the end for the DT4. This DT4 actually you can leave it. If you want to set, it's okay. If you do not want to set, you can leave it behind. So for save sometimes I do not define the end DT4 and end DT6 opcode. I just directly use locator. I will directly set the end will be enough. This will be enough. So for this locator, all the devices need to set, because for the BE, they only care about the source and destination, it will be enough. But for the SR, since we need to planning the path, so every devices needed to set the locator and set the OP code. So let's do it here. Segment routing IPv6. What's that? The encapsulation source and the locator SR&SRv6 IP prefix. static 16. And opcode function 1, this will be used as an end. Let's do the copy and paste. 3 and 3 so will be used for P3. For this, we already configured. This is 5 and 5. 5. And 6 and 6. Okay, and after that, we need to use the what's the SS? We need to use SS to advertise all this, to advertise the locator. We need to advertise the locator. Use SS. Wait a moment. Use SS to help us to tell others like what is my end seed. So Is P1, P2 to the configuration? Wait, let me check. Yes, this P1 already do the configuration. Okay. Now we can planning the now we can planning the path. About this, we can do the configuration later. About this, we can planning the path first. Okay, let's planning this path first. Okay, so here is the path for the P1. Segment list P1 to P4. And let's just do the VPN A. Okay, path 1. And index 5 seed IPv6. This is from FC00 colon. Because I changed the how do I say this? I changed the locator. So you can follow this locator, but I use myself's locator. Colon 1. This is index 1, and there's another index seed because I was going to P4, so the next hop will be P4. C00 colon 4 colon 1. Okay, so this is for the one segment list. Let's do another. This, let's change the path seed IPv6. First hop is still P1. And the next hop, let's go into P2. Then let's go to PE4. Wait a moment. Going to P2. Yes, this going to P4. Yeah, this is right. And here is some path I configure is not correct. Let me change the path. This should be index 10. I gave to 5 first, then 5 gave to going to P3. Then going to P4. Okay. So so to save some time, I just write 2 paths, and it will be enough. But if you want to write 3 paths, this is also okay. Now let's create some candidate. Let's create some policy. This is SR&SRv6 policy, and the endpoint will be the this endpoint should be same with the next hop for the BGP root. Okay, and the color, let's put 150. And let's create some candidate path. Candidate path preference 100, segment list P1. Okay, and let's create another candidate path, preference 50, segment list P2. Okay. Now this is for the P1 to P4. Let's create some. Let's set the path for from P4 to P1. Segment list P4 to P1. First path. Index 5. Seed. So this one, the first hop will be PE2, P2. Then next hop will be P2, P2 going to P2. Then going to P1. Okay. And let's create another segment list PE4 to PE1. Second pass. First, it's going to P2 and then going to P1. Okay. And then last hop will be P2 go to P1, P1 go to P1. Okay, this is a second list, and let's create some policy. 6T policy. Give it a name, SRv6 policy, and the endpoint will be the next hop. And the color will be 150. Let me think. Already configured, so I should give it. Yeah, let's just stick with 150. Will it go a problem? No. Okay. Then let's create a candidate path, preference 100, and let's put the segment list PE4, and let's get another candidate path, preference 50, another path, and the path will be from P4. This is the second path. Okay, now we just after we define the two paths, we can use this policy to help us to select the path. So at P1, internal policy SRv6, internal select sequence IPv6 SRv6BE. Load balancing number 1. Okay. Then in P4, we also set the policy. Internal select sequence IPv6 SRT policy load balancing number 1. And let's put it into the VPN instance. Okay, let's put the internal policy SRv6. for eVPN. For eVPN. Then let me think. We need to change the default. We need to change the default color to 150 because the SR&SRv6 policy, the color we use is 150. Okay, for the PE4, we do the same thing. Kernel policy SR&SRv6. Default color, this will become 150. Because kernel we use is 100. Oh, sorry. There's some configuration wrong. This will be used for eVPN. Okay. Now after this, we can just do a little bit. Oh, default color also. Wait a moment. Default color, I also need to configure the eVPN. Wait a moment. Okay, now we can check the result. First, we need to check the kernel info. So we can say there's a kernel here. There's a kernel here, and in the PE4, you will also see a kernel here. This kernel is manually configured based on this. After we finish this configuration, the kernel will be established. Now we need to let's check. We need to do the configuration for the. Let's check. I guess the BGP already gets the VPN v4 or routing table. See if they got the. Yes, they got it. They got the root entrant. And let's check eVPN or routing table. And for the root entrant, yes, we also have. Okay, this one we already have. Let's check. This one we already have. There's no information for eVPN. Wait a moment. Let me check it. There's some configuration. I guess I haven't finished. Wait a moment. IPv6. I didn't finish the configuration. Let me check. Yes, I haven't finished the configuration. And segment. me check. We haven't finished the configuration for IPv6. Just, yeah, I forgot for this one. Segment IPv6 locator, use SR&SRv6 eVPN and IPv6 traffic engineering eVPN. Best effort should be. This second one means if the TE failed, I will use the best effort. Okay, now I guess it will be okay. Let me check. Yes, we have it. Now let's at last let's check the routing table. Let's check the detail. Still using the BE. Wait a moment. Display kernel info. Oh, yes, we have the policy. The next hop will be no. This is not right. Wait a moment. Let me check. I get it. I get information. Advertise to level 2. Will be no problem. Oh. I think there's some configuration wrong here. Wait, let me check. Kernel policy. Okay. Undo kernel policy. SR. Undo kernel policy. SR&SRv6 undo VPN target. Wait a moment. There's a little bit of problem. Wait a moment. Yes, this will be right. Okay. Oh, this one I was using. Oh, I know what's the problem. Ah, damn. Root target. No. VPN target. And the tunnel policy will be SRv6. Okay, this will be right. Okay. Because for IPv4, I'm not using eVPN. I was using VPN v4. So I should not set the eVPN configuration. Okay, now it should be right. Let me check it again. Display, IP routing table. VPN instance, VPN A. Reverse. Well, still going to be. For the wrong prefix is this. There's some configuration I haven't deleted. Let me check. Here. Traffic best effort. Okay. Wait a moment. Traffic best effort. Okay. Then it should be okay. You can see it's policy. There's some configuration I haven't deleted because I do the best effort before. So that some configuration is not right. But anyway, now we can see we are using the tunnel ID right now. And this tunnel ID will be equal to this. And this is for the IPv4. Let's do the ping test first. Ping VPN instance, VPN A. The reply got a problem. Let's look at here. Display IP routing table, VPN instance, VPN A. Yeah, it should be right. SR policy should be okay. Display. SR policy. Wait a moment. Let me do a little bit of troubleshooting. T policy. Five, 3, 4, 1. 5, 4, 5. There's no 6. Where's 6? Did I not do the configuration? Wait a moment. SS1. Yes, already do the configuration. Segment routing IPv6. Locator. Oh, I configured this wrong. Undo locator. Sorry, 6. Undo. Sorry, there's some configuration I did is not right. Undo locator, SRv6. Locator, SRv6, IP, FC00, colon 6, colon 96, static 16. This will be right. And IPv6 locator, SRv6. Okay. Let's do the test again. First, checking the routing table. 4, 5, 6. Should be okay. Let's check. Let's ping the RSP. It should be okay. Oh, yeah. Should be okay. Let's check the IPv6 first. Not root entry coming. Display BGP, EVPN. or routing table. Oh, there's no information coming. Wait a moment. IPv6. This is let's check it here. Yes, they have the root entry. Let's look at the detail. Have the RT, have prefix ID. This for VPN. No color is needed. I do not need no color. RT is this. It should be okay. Display BGP eVPN. Oh, did I? Undo. Yes, it's all being undo. It should have. Why is wait a moment. Undo policy. Why P1 do not sending it to me? Oh, damn it, I forgot. Reflect client. Okay, that will do. I forgot. Okay, here it comes. And let's check the IPv6 routing table using VPN A. Reverse to see if we also have. This is also for BE, but the tunnel. Oh, there's no tunnel. Tunnel policy SR&SRv6 eVPN. Okay, that will do. Then it will go into the SR&SRv6 policy, so this will be okay. And then let's double check. It should be no problem. Tunnel policy, nope. Okay, let's do the test. Ping. Let me do one last check. If still got a problem, I will try to fix later. The P should have got no problem for configuration. Wait a moment, let me check. Am I missing something for P1? I don't remember I configured all configuration. South, it should be right. Is there anything I haven't configured? Circuit. Which part I forgot configuration? I think there's no. Let me do one last check. If there's still problem today, we just finish. We will try to solve this in some other day. Encapsulation, OP code, it should be okay. There is not such things. It is up, it is active, should be okay. The first is from 4, from 5 to 3 to 4. Yeah, should be okay. P3 to P4. Yeah, should be okay. Cool wall, single wall. There should be no problem. The color is 150. Yeah, it is right. It seems all okay. Don't know what is the problem. Hmm? There's no such root entry. Oh. Okay, this should be okay. Okay, this seems okay. It must be some configuration wrong for the SRv6 policy, but today we do not have enough time to do a troubleshooting. Some other days. Let me do one last try, and if it cannot succeed, today we just for this. Some other time we'll try to deal with it. VPN8. Some other time we'll try to fix it. There must be some configuration wrong for the SRv6 policy, because you can see all the root entry is already going to this kernel already, but when it come back, it might got a little bit problem. But anyway, we find some other time to deal with it. Okay, today we just like this. For last lab, the policy, the SRv6 policy in the middle point, there must some wrong in the middle, but I do not have enough time for troubleshooting today. Some other time I will fix it. Okay, so today it will be just it, and we'll see you guys tomorrow.